context-free languages. Do you remember? Chomsky normal form. This was completed yesterday. Hello? Hello? Please, anybody respond? Okay. So, today I start the push-down automata. Now tell me, is this regular or not? L equal to A power n, B power n, n greater than or equal to 0. Is this regular or not? Why? Smita, why this is not regular? Okay, good. Relation and infinite. So here, A power n, B power n, A's followed by B's, and whatever the number of A's, that many number of B's has to be there in the language. In any string, whatever the string you take from this language, whatever the number of A's, that many B's has to be there. So whenever A's comes, you have to count. Whenever B's comes, we have to count, and we have to check these numbers are equal or not. So for this, a memory is required. But a finite automata does not have the memory. Therefore, we cannot construct a finite automata to accept this language. Hence, this language is not regular. This language is not regular. Now, if this is not regular, means if this language is not accepted by finite automata, then what kind of automata will accept this language? The automata which can accept this language is push down automata. If finite automata cannot accept, PDA can accept this language. Okay, so when PDA is accepting, whether it is a PDA or any other automata, when it is accepting this language, it must check whether A's and B's are equal or not. I repeat, whatever the automata is accepting this language, so it has to verify whether A's and B's are equal or not. Suppose A power 4, B power 4. Yes, here A's are 4 and B's are 4. These are equal. So to verify whether A's and B's are equal or not, we must require a memory. Yes, PDA has the memory. Just now I told you, this language is not accepted by finite automata, as memory is required. There is memory required, but a finite automata does not have the memory, so we cannot construct a finite automata to accept this language. But this language can be accepted by push down automata. Okay, whether push down automata or any other automata, when it is accepted in this language, it has to check whether A's and B's are equal or not. For that, a memory must be there. Yes, a PDA has the memory. That memory is nothing but a stack. A stack will be used as a memory. What is a stack? We can call this as stack or PDS, push down store. It is stack or push down store. Okay. In stack, a stack is used to push or pop the symbols. I repeat, in the stack we can push the elements or we can pop the elements. Meaning we can push or delete the elements from this stack. And here, the main objective of PDA is it is used to accept context-free languages. The main objective of the PDA is it is used to accept context-free languages. Okay, and the memory in the PDA is nothing but stack. In the stack can be used to push or pop the symbols. Okay, now take the notes. PDA is used to accept PDA is used to accept context-free languages. PDA is used to accept context-free languages. Okay, next in PDA, a stack in PDA a stack or push down store, PDS, push down store will be used as a memory, which can be used to push or pop the symbols of the grammar, push or pop the symbols, or just you write like this, push or pop the symbols, that's enough. Okay, now we see the complete structure of the PDA. A PDA is a 7-tuple. It is a 7-tuple. It is 7-tuple. Generally, we represent the machine Q sigma tau, Q sigma tau, del, Q naught, Z naught, and F. Okay. And what is Q stands for? As usual, it is finite non-empty set of states. Q is the finite non-empty set of states. Means the number of states must be countable and a minimum one state must be there. If there are no states, it is not at all push down automata. So finite non-empty set of states. And sigma is the finite set of inputs. Sigma is the finite set of inputs. Next, tau. Tau is the finite non-empty set of stack symbols or push down symbols. Just now I told you before this structure, in PDA a stack will be used and the stack will be used as a memory, and in the stack we can push the elements, means we can store the elements, or we can pop the elements, means we can delete the elements. So whatever the elements we are pushing and popping, all these symbols called as push down symbols or stack symbols. So all the symbols whatever we use in the stack, those symbols will be in tau, in this tau. Okay, so tau is the set of stack symbols. Okay, this is finite. The set of stack symbols are also finite and non-empty. Tau is non-empty, means minimum at least one symbol must be there in tau. Okay, finite non-empty set of stack symbols, or you can say push down symbol. Next, this is the transient function. I repeat here: Q set of states, sigma set of inputs, and tau set of stack symbols or push down symbols. And this is transient function. What is this transient function? We will see later. Just now you just look at this. It is mapping. It is defined like this: Q cross sigma union epsilon cross tau into Q cross tau. I will explain this in detail after this. Okay, just leave this for a while. And Q naught. Every finite automata must have the initial state. That similarly, PDA also must have the initial state. Means it must start from that state. So Q naught I am taking as initial state, and this is also one of the states from Q. And Z naught. What is the Z naught? I told you in PDA, stack will be used as a memory. Okay, whenever the PDA starts, there will be only one symbol in the stack. That symbol is nothing but Z naught. I repeat, whenever PDA starts, there will be only one symbol in the stack. That symbol is nothing but Z naught. This Z naught we call it as initial stack symbol. Okay, So every time when the machine starts, there will be only one symbol in the stack. That symbol is nothing but initial push down symbol or initial stack symbol. And this initial stack symbol is one of the symbol from the tau. That is the reason tau is non-empty, finite non-empty. So tau is a set of stack symbols. So Z0 is belongs to tau. That is the reason minimum Z0 will be there. That is the reason for tau is non-empty. Okay, this one. Now. So this is initial stack symbol and it is one of the symbol from tau. Next, F is a set of final states. A PDA can have zero final states, means no final states, or it can have one final state, or two, or three, or four, or any number of final states. So a PDA may or may not have the final state. If it has, it can be 1, 2, 3, 4, any number. Okay, this is the structure of the push down automata. It is a 7 tuple. Okay, Q, sigma, tau, del, Q naught, Z naught, F. So copy this one. Rishikesh, Samiksha, and who is this Riya Vyas? New student. Why are you late today? I have waited almost 35 for 30, more than 35 minutes. I have waited for you. Okay, if you are doing like this every day, I will lose the interest. Okay, I don't have the interest to teach you. For a teacher, the punctuality is very important. Okay, I can wait maximum 5 minutes, but like this, waiting for 35 minutes and 40 minutes, so I can't take class effectively. Please understand my point. And if you have any work, you just tell me. I can start the class at your convenient time. Instead of 5, I will start 5:30. Why should I start the class at 4:45 and waiting for you more than 45 minutes? You understand? And this is a new topic. I cannot start if you are not there. Only except as a no one has joined at the right time. Everybody late today. Okay, copied. Hello, copied. Next. Okay. Here everything is clear. Set of states, Q, set of inputs, set of stack symbols tau, and Q naught is initial state, Z naught is initial stack symbol, and F is a set of answers, maybe 0 or more. Everything is clear. Except this one. Okay. Now, this is the transition function. It is defined like this: Q cross sigma union epsilon cross tau into Q cross tau star. Okay. For a while, just leave about this union sigma. Okay. It is Q, means in every transaction it takes a state Q from the set Q, means simply in every transaction the PDA takes a state cross sigma. Sigma is set of inputs. So in every transaction takes an input symbol cross tau. Tau is a set of stack symbol. So in every transaction it takes the state and input symbol and stack symbol from the stack. Or suppose this is the stack and suppose these are the symbols in the stack, and in every transaction it takes the topmost symbol only, this symbol. Suppose this is X, Okay, x1, x2, x3, like this, x4. So whatever the topmost symbol in the stack, that symbol will be taken by PDA. So when x1 is the top symbol, it cannot take any of these three symbols in this particular transaction. So every time the PDA takes only the topmost symbol. Let Z is the topmost symbol. So in every transaction, the PDA takes the state and input symbol and topmost symbol from the stack. Okay. After completion of this transaction, the PDA will, this is Q, will give another state. Means it may change the state or it may remain in the same state. So now at present in this transaction the state is Q. After completion of this transaction the state may remain in the same state or it may go to Q dash. So that is depends on the requirement. So here clearly after completion of this transaction the state may or may not change the state. And here this alpha, what is this alpha? Alpha is tau star, means after completion of this transaction this alpha indicates what this alpha tells you what to do in stack, what to do in the stack. Okay, that we will see later. So simply this is the elements of the transition function, this one, are of the form, look at this, del of q means it takes a state, comma a means it takes the input symbol, comma z means it takes the topmost symbol. So in every transaction take the state and input symbol and the topmost symbol, and after that it tells you, it gives you what is the next state and what to do in the stack. So simply now take the notes. The elements of the transition function, take the notes. The elements of the transition function are of the form, the elements of the transition function are of the form, copy this one, del of q comma a comma z equal to q dash comma alpha. Del of q comma a comma z equal to q dash comma alpha, where q comma q dash belongs to q, means these two are the states, this q and q dash, and a is an input symbol and z is a stack symbol, this one, and alpha is set of stack symbols. So copy this one. The elements of the transition function are of the form del of q comma a comma z equal to q dash comma alpha, where this condition. Okay, now I'll tell you clearly what happens after every transaction. You just listen. Even though you don't understand, or if you understand only 50% or only 30%, okay, don't worry. At the end of the class, you will get everything. Okay, just listen the class. Copy it now. Suppose at present, this is the situation. At present, this is the situation. The machine is in Q0. The machine is in Q0 here, and the string is ABBA, and the symbols in the stack are Z2, Z1, Z0. The symbols in the stack from top to bottom. This is the top symbol. The symbols in the stack from top to bottom. The top symbol is Z2, and below that Z1, and below that Z0. These are the symbols in the stack from top to bottom. And the input string to be scanned is ABBA. Suppose this is the input string. The finite automata, I'm talking about the finite automata. Finite automata scans the input string from left to right. And starting from the leftmost symbol, the string will be scanned towards the right side, and every time the finite automata scans only one symbol. First it scans this symbol. It will perform some transaction. After that, it will move to the next symbol. Then it takes this symbol. After that, it will move to the next input symbol. It takes this input symbol, and it will perform some transaction. Then it will move to the, like that. The finite automata scans the input string from left to right, starting from the leftmost symbol. Every time it scans only one symbol. It cannot scan the two or more symbols at a time. The same way, PDA also scans the input string from left to right. PDA also scans the input string from the left to right, starting from the leftmost symbol. First, it takes the symbol, it will do some transaction, then it will move to the next input symbol. Okay, and here it will take this input symbol, it will perform some transaction, then the machine move to the next input symbol. Again, it takes this input symbol, it will perform some transaction, then it comes to this, and again it takes this input symbol, it will perform some transaction, and it will go to the next input symbol like this. The input string will be scanned one by one, and start from the leftmost symbol, it moves to the rightmost symbol. The PDA cannot take two or more symbols. The PDA cannot take two or more symbols at a time. It can take only one symbol at a time, as in the case of finite automata. Okay, now suppose this is the situation at present. Let the machine is in Q0, and this is the input string ABBA, and the string scans the input string from left to right, and in every transaction, it takes the leftmost symbol. This is the present input symbol, and these are the symbols in the stack from top to bottom, Z2, Z1, Z0. In every transaction, the PDA takes the topmost symbol only. Here, what is the topmost symbol? Z2. So, in every transaction, it takes the present state and present input symbol and the topmost symbol from the stack. So, Q0 A Z2. Okay. Now, so this is the scenario. Now this is the situation. Now, you remember we have done some designs of finite automata. We have constructed some DFAs and NFAs. So we have constructed different DFAs for different languages. So similarly, here PDA also, the design of the PDA depends on the requirements. Teja, so if you are not audible or if my screen is not visible to you for more than half minute, just give me a call, because sometimes I may not notice that my internet connection or any technical problem. Okay. So what happened today, I have taken the class and my internet connection was interrupted. I didn't check. I didn't notice for more than 10 minutes. I keep on giving the lecture like this. But after some time, students call me. Then only I came to know that there was a technical problem. Okay. If anytime, if it is not visible to you, okay, the screen is not visible, or if my voice is not audible to you for more than 30 seconds, just give me a call or just alert me anyway. Okay. Now, here Q0 A Z2. So every time the machine takes the present state and present input symbol and the topmost symbol in the stack. Okay. Everything depends on the requirement. Now I am defining the move like this. If the machine is in Q0 and if input symbol is A and top symbol is Z2, look at this, I am defining like this. You just don't bother about this, how I am writing, why I am writing, how to write this. Just you don't bother, just leave everything. You just try to concentrate the meaning of this entire move. Do you understand what I'm saying? You don't bother about all these moves, just you concentrate on what is the meaning of this move. So how to write and what to write, that all we will see at the time of design. Okay. Now here, what is the meaning of this move? Here, if the machine is in Q0 and if input symbol is A and if the topmost symbol in the stack is Z2, then go to Q0. What is the state here? Q0. And what is the state here? Here also Q0. Means simply don't change the state. be in the same state only. And here what I wrote epsilon. Actually, this part represents to the stack. Here what is the stack, topmost symbol in the stack? Here the topmost symbol in the stack is Z2. Okay. Here that Z2 I didn't write. Instead of Z2, what I wrote here, I wrote epsilon. This means you delete the topmost symbol Z2 from the stack. That is the meaning of this epsilon. Do you understand? I repeat. Whenever machine is in Q0 and input symbol is A and the top symbol is Z2 and B in the same state and delete the Z2 from the stack. That is the meaning of this one. Okay. Now, so this is the present situation. Now after this, the machine will be in the same state because we are not changing. And I told you the string will be scanned one by one. Now it has scanned A. And for the remaining string is BBA, okay, and this Z2 is deleted, so delete this Z2 as per this epsilon. If I delete this, then the remaining symbols in the stack will be Z1, Z0. Do you understand? Okay, now, so Z2 is deleted. Now, every time the machine takes the present state. What is the present state? Q0. And present input symbol. What is this? B. And topmost symbol in the stack. What is the topmost symbol in the stack? Z1. Okay. I am defining the move like this. If the machine is in Q0, if input symbol B comes, if the topmost symbol is Z1, I am defining like this. Q1 comma Z1. You just try to understand the meaning of this one. Sir, how you are writing these moves? I don't know. I want to say something, I want to explain something, whatever comes in my mind, I am writing here. So there is no logic here because we are not doing any design. I want to explain the meaning of the moves. So you just concentrate on the meaning of this moves. So what is the meaning of this move? Here del of Q0 comma B comma Z1 means whenever the machine is in Q0 state and if input symbol is B and if the topmost symbol in the stack is Z1, then change the state to Q1. Change the state to Q1 and what I wrote here Z1 and what is the top symbol here Z1. So Z1, the same Z1 I wrote here means you don't disturb the Z1, don't touch the stack. You just keep the stack as it is. Whatever the top symbol Z1, you just remain it. Don't make any changes in the stack. So as per this, what will happen here? Okay, here from this, okay, here Q0 B Z1, this Q0 B Z1, this present situation is matched with this move, with this one. Okay, there may be hundreds of moves and every time the PDA will check for the present condition with the corresponding move. So this present situation matched with this move. So Q0 B Z1, what happens? Change the state to Q1. After scanning this B, what will be the remaining input string? BA and Z1. What to do Z1? Just keep the Z1 as it is. So for the remaining, for the next transaction, the stack symbols will be same, Z1 and Z0. Okay. Do you understand? Next. Here, for this transaction, what is the top present state? Q1. What is the present input symbol? B. What is the topmost symbol? Z1. Q1 B Z1. Okay. What to do this? Everything depends on the design. Okay. I am designing the move like this. Q1. If the machine is in Q1 and input symbol is B and if the top symbol is Z1, I am defining like this. Q1 comma A. Guys, just you please try to understand the meaning. Here, what does it mean? Whenever machine is in Q1 state and input symbol is B and the top symbol is Z1, don't change the Q1. Don't change the state. So B in the same state. If you observe this one, in this transaction, Q0 is the state and result is also Q0 is the state. And in this transaction, if the machine is in Q0, it has changed to Q1. And again here, if the machine is in Q1, the state will be in Q1 only. So every time after completion of the transaction, the PDA may may change. Here it has changed or may not change. So simply after each transaction, the state may or may not change. Okay. And here in this transaction, the top symbol is deleted. Z2 is deleted here. And in this transaction Z1, we kept the Z1 as it is. And here, what does the meaning of this whole move? If the machine is in Q1 and input symbol is B and the top symbol is Z1, B in the same state. And here what I wrote, A. I wrote A. Actually, what is the top symbol here? Z1. Did I write the Z1 here? No, I didn't write. Instead of that, what I wrote A. This means you delete the Z1 and you push A into the stack. Simply, you delete the Z1. In the Z1 place, you write the A. Simply, you replace Z1 with A. Okay, come to this. Come back. Here, Q1 and B, Z1. This present situation is matched with this third move. So what happens here? Same state. Okay. Here, whenever the machine scans the input string, for the next transaction, the input string will be reduced. So this is scanning B. So for the next transaction, A will be the input string and Z1. What I did here? So replace Z1 means delete the Z1 from the stack. In Z1 place, you just write A. So simply replace Z1 with A. So A Z0. Do you understand? Okay. Instead of this, if I write like this, what is the meaning of this one? Guys, please concentrate here. If I write like this, what does it mean? Okay, look at this. Z1 is the topmost symbol here. Did I write the Z1? Yes, I wrote the Z1. But before that, what I wrote A. Means after completion of this transaction, whatever the top symbol Z1, you just keep as it is. And before that, what I wrote A. So just Z1, you keep the Z1 as is. And on top of Z1, you push A. That's the meaning of this transaction. So A, then Z1 followed by Z0 means in below that. Okay, so this Z1 you can replace with one symbol, or keeping the Z1 you can add one symbol, or if I write like this AA Z1. Just look at this. If I write like this Q1 comma, if I write like this AA Z1, what does it mean? This means keep the Z1 as is. And on top of Z1, you push 2s. So this is the meaning of it. And if I write AAA Z1, means what does it mean? You keep the Z1 as is and push 3s like this. So by keeping the topmost symbol, we can push one symbol or two symbols or three symbols or four symbols or five symbols or 100 symbols. Any symbols, any number of symbols you can push by keeping the topmost symbol. Or if I write like this, only, means A only, what does it mean? This means you just replace Z1 with A, means delete the Z1 and push A. If I write like this, what does it mean? You delete the Z1 from the stack. And push 2A's in the stack. And if I write like this, what does it mean? You delete the Z1 and push 3A's or push 4A's or push 5A's like this. So finally, whatever the topmost symbol, we can delete here in this case, or we can keep as it is. See, Z1 is kept as it is. Here Z2 is deleted and here Z1 kept as it is. Or the topmost symbol we can replace with one symbol, or by keeping Z1 we can add one or more symbols, or by deleting Z1 also we can push one or more symbols. So finally, what I want to say is, suppose if these are the symbols in the stack, Z3, Z2, Z1, Z0. There are four symbols in the stack. So in every transaction, the machine takes only the topmost symbol. When Z3 is the top symbol, it can take only Z3. It cannot take any of the symbols below symbols from the stack. Okay, I repeat. When Z3 is the top symbol, the PDA can take only Z3. It cannot take any of the symbols below the Z3. Okay, now after completion of this transaction, I repeat, this is the Z3 top symbol. It will take Z3. After completion of this transaction, this Z3 may be deleted, or this Z3 can be kept as it is, or we can add one or more symbols in the stack by keeping the Z3. Means we keep the Z3 as is and we can add one or more symbols, or this Z3 we can replace with one symbol. Okay, or means or by deleting Z3 we can add one symbol or two symbols or three symbols or any number of symbols. So I repeat, we can keep the Z3 as it is and we can add one or more symbols, or by deleting also we can add one or more symbols. But here, when Z3 is the top symbol in this transaction, whatever the symbols below the Z3, what are they? Z2, Z1, Z0. These symbols Z2, Z1, Z0 cannot be modified. Means you cannot touch any of these symbols which are below the Z3. So when Z3 is the top symbol, we can do anything with Z3. We can add any number of symbols on top of Z3, or by deleting Z3 we can add one or more symbols, but we cannot touch any of the symbols below the Z3. Means in this particular transaction, I will delete Z3 and also delete Z2. No, it is not possible. You cannot touch the Z2, or you cannot replace Z2 with any other symbol. Only what you can do is you can do anything with the Z2, but you cannot touch this. Suppose, guys, listen this carefully. Suppose in this transaction the Z3 is deleted. In this transaction Z3 is deleted. Okay. For the next transaction, what will be the top symbol? For the next transaction, the top symbol will be Z2. Now Z2 is the top symbol. So in this transaction, the machine takes the Z2 because Z2 is the top symbol. Now Z2 can be deleted or replaced, or we can add one or more symbols, whatever we can do. But you cannot touch any of these symbols which are below the Z2. Okay, na? So finally, in every transaction, the PDA takes the present state and present input symbol and the topmost symbol from the stack. After completion of every transaction, the PDA may or may not change the state, and the input string will be scanned one by one. And coming to the stack, the top symbol in the stack may be deleted or kept as it is, or we can add one or more symbols in the stack. Okay, take this point. Hello, are you there? Hello. Guys, are you there? Okay. Take the notes. In every transaction, the PDA takes the present state and present input. I repeat, in every transaction the PDA takes the present state, comma, present input symbol, and the topmost symbol from the stack. Full stop. After completion of each transaction, the PDA may or may not change the state. The PDA may or may not change the state. The PDA may or may not change the state, and the topmost symbol in the stack may be deleted or kept as it is, or kept as it is, or one or more symbols can be added. One or more symbols can be added on top of the stack. By deleting or keeping the topmost symbol. By deleting or keeping the topmost symbol in the stack. So what is the meaning of this last statement? Hello. Now the topmost symbol is Z2. So it takes this Z2 for this transaction. By keeping this Z2, we can add one or more symbols on the top of the stack. Or by deleting this also, we can add one or more symbols. That is the meaning of this last statement. Okay? Full stop. But, continue. But, the symbols which are below the topmost symbol. But the symbols which are below the topmost symbol will not be get disturbed. Will not be get disturbed. Okay. Next heading. Instantaneous description, ID. Instantaneous description, ID. Guys, what is an ID? This is an ID. This is an ID. And this is an ID. And this is also an ID. ID means the ID tells you what is the present state, what is the present string, what are the symbols in the stack that will be given by ID. Suppose this is ID. Q0, A, B, B, A, and Z2, Z1, Z0. This means Q0 is the present state, and A, B, B, A is the input string to be scanned, and Z2, Z1, Z0 means the symbols in the stack are from top to bottom. From top to bottom is Z2, Z1, Z0. So this is an ID. So in general, what is an ID? So ID tells you what is the state Q and what is the input string W and what are the symbols in the stack, that is alpha. This is an ID. So that is okay. An ID is del of Q comma W comma alpha. An ID is del of Q comma W comma alpha, where Q is the state, W is the input string, W belongs to sigma star, and alpha is a set of stack symbols. Alpha belongs to tau star. Copy this. Next, initial ID. Initial ID. Okay. Suppose this is a PDA. Q, sigma, tau, del, Q0, Z0, F is a PDA. By writing like this, what will you know? You will know what are the states. What are the states in Q? What are the input symbols in sigma? What are the stack symbols? And what is the initial state? What is the initial stack symbol? Q0 is the initial state. Z0 is the initial stack symbol. And what are the final states? Everything will be known by giving this structure. Okay? From this structure. So if M equal to is a PDA, then the initial ID is, actually what is the ID? This is the ID. Q, state, and input string W and alpha, stack symbols from top to bottom. So if this is a PDA, then the initial ID is, what is the initially? Means whenever the machine starts, there will be only one symbol in the stack. that is nothing but initial stack symbol. That is Z0. This one. I repeat. Whenever the machine starts, there will be only one symbol in the stack. So whenever the machine starts, the machine has to start from initial state. What is initial state? Q0. And input string, it can be anything, maybe a valid or invalid. Okay, Q0 W. And what is the symbol in the stack? Only Z0. So this is called initial ID. That is what I wrote. If M equal to is a PDA, then initial ID is. Copy this one. Where W belongs sigma star. Q0 is initial state. We have told here. And Z0 is, this means it is the initial stack symbol. And W is sigma star. Okay. Next. Done. Next. Here, actually del is mapped from Q cross sigma union epsilon. What is this sigma union epsilon? Suppose sigma is A comma B, then what will be sigma in epsilon? This means sigma is A and B and union epsilon. This is, that is okay. What does it mean? Means in every transaction, it takes the state from Q and it takes the symbol from sigma union epsilon. Sigma is A and B. So it can take A or B or it can take epsilon. Means it can, okay, just hold on. And what is this? It is a stack symbol. This means it can make a transaction by taking the state and top symbol and epsilon. What does it mean? It means it can, the PDA can make a transaction without taking the input symbol. Actually, what is the input symbol here? A and B. It can take A and or B or epsilon. Means the PDA can make a transaction without taking the input symbols. Such moves are called as null moves. Okay, do you understand? So even though okay, just I will tell you what is the meaning of this one, how exactly it works. Okay, just listen this one. Okay, now this is the present situation. Yes, the machine is in Q1. The machine is in Q1 and input symbol is B and the top symbol is Z1. I repeat, the machine is in Q1 and input symbol is B and top symbol is Z1. So del of Q1 comma B comma Z1, I have to define something. But I don't define anything for this move. Means I don't require. So in the PDA, you need not to define for every state and every symbol and every stack symbol. In PDA, you need not to define for every state, for every input symbol, for every stack symbol. Whatever we required, we must define for them only. So if I don't require a move, I don't define. If you are not defining, then you need not to write like this. Just forget it. Don't write anything. I don't write this. Okay, like this. The present situation is Q1 and B is the state and Z1 is the top symbol. I don't require this. Means I don't define. That is empty. When it is not defined, the machine stops here. Okay, but here I am defining it. move differently. Look at this. Q1 comma epsilon comma Z1. Guys, just concentrate here. Q2 comma A something. Okay, I'm defining like this. What is the meaning of this one? Hello? What is the meaning of this one? Here, the meaning of this one is when the machine is in Q1, when the PDA is in Q1 and when the input string is empty, no, it is not the meaning like that. It is not the meaning like that. I repeat, the meaning of this move is when the machine is in Q1 and when the machine is in Q1 and if the top symbol in the stack is Z1, when state is Q1 and top symbol is Z1, then don't take the input symbol. That is the meaning of this epsilon. Whether there is an input string, if there is a symbol in the input string, or I repeat, whether there is an input string or not there. Okay, when Q1 is the state and top symbol is Z1, don't take the input symbol, just you do the transaction without taking the input symbol. That is called a null move. Okay, what to do? Just go to the state Q2 and replace A with Z1. So what happens here after this? After this here, so Q1 is the state, okay, and Z1 is the top symbol. Yes, it is matched. Then it don't take this input string. It don't take this input string. So what happens here? It will go to Q2 as it is defined, and it has not scanned the input string. So BA, the same input string will be continued, and Z1 will be replaced with A, and this is the result of the null move. Okay, do you understand? So what is the null move? Okay, take the notes. Take the notes. Sometimes the PDA can make a transaction. Sometimes the PDA can make a transaction without taking the input symbol. Without taking the input symbol. So guys, continue. Write this within brackets. Continue to that. Continue the previous one. Okay. Sometimes the PDA can make a transaction without taking the input symbol. Okay. Write this in brackets. Like in brackets. That is del of q comma epsilon comma z. Okay. Close the bracket. Close the bracket and continue. Such moves are called as null moves. Such moves are called as null moves. Okay. So here we have seen the complete structure of the PDA. What happens in every transaction? What is an ID? What is an initial ID? What is null move? We have completed all this. Okay. Now, take the note. Take the note. In PDA, it is not necessary. It is not necessary to define for. It is not necessary to define for every combination of in PDA. It is not necessary to define for every combination of, copy this guys, del of q comma a comma z. Already I told you, for every state, for every input symbol, for every stack symbol, you need not to define. Whatever we required, we must define for them only. Okay. For every combination of del of q comma a comma z, where q belongs to q is a state, a belongs to sigma, a is an input symbol, and get dropped out. We get this number. Okay. So next, do you understand at least 50% or 40% of this concept? Please respond. Hello guys, I told you what is the structure, what is ID, what is initial ID, okay, and what is null move. Okay, now take the heading acceptance by PDA. Acceptance by PDA. A PDA can accept the strings in two ways. Take the notes. A PDA can accept the strings in two ways. First one, by final state, and second one by empty stack. By final state and by empty stack. Copy these two. Okay. Now tell me, how do you say a string is accepted by? How do you say a string is accepted by finite automata? Kiran. Kiran, how do you say that a string is accepted by finite automata? Rishikesh, you can use your mic. Hello? How do you say that a string is accepted by finite automata? Samiksha? Samiksha, do you have mic with you? How do you say that a string is accepted by finite automata? Smita?
So,
How do you say a string is accepted by finite automata?
so when finite automata scans the entire string and when it reaches the final state after scanning, then we call it as that the finite automata accepted that string.
Please repeat.
So when the finite
I want the complete definition.
So when finite automata scans the entire string and if after scanning it reaches the final state from initial, then we call it as string is accepted by that finite automata.
Good. Very good. Okay guys, listen. In the case of finite automata, it has to start from initial state. And whatever the string, suppose this is a string, it has to scan the input string completely. And when the machine stops, it has to stop in a final state. Then the string is said to be accepted. So three conditions. One is it has to start from initial state. The string must be scanned completely and it has to stop in a final state. The same way, here the PDA can accept the strings in two ways. One is by final state and the other one is by empty stack. So what are these? We will see one by one. First one, by final state. Okay, suppose this is the PDA, Q set of states, sigma set of inputs, tau set of stack symbols, del trans function, Q naught initial state, Z naught initial stack symbol, F set of final state. Okay, if this is the PDA, then the set of all strings accepted by PDA by final state are defined as. Simply guys, don't worry about this one. Simply I am giving you the structure. If this is the PDA and then the strings accepted by this PDA, I am defining as T of M. T of M, M is the machine and it is accepting the strings. Strings means what? Combination of input symbols. You can see this one. W is belongs sigma star. The set of all strings accepted by this machine are represented as, defined as, T. In the case of finite automata, it has to start from initial state. In the case of finite automata, it has to start from initial state. Whereas in the case of PDA, it has to start from initial ID. I told you what is initial ID. It has to start from, this is initial ID here. It has to start from initial state and initial stack symbol, and W, the string can be anything. If it is valid, it will be accepted. If it is invalid, it will be rejected. So by final state, the string has to start from, the machine has to start from initial ID, that is Q naught, W, Z naught. Okay. The star indicates after one or more transactions, when the machine stops, definitely the machine will stop. And when the machine stops, it has to stop in one final state. It has to stop in a final state, and whatever the string we have taken, that string must be scanned completely. Okay, it has to start from initial ID, and when the machine stops, it has to stop in a final state, and when the machine stops, the string must be scanned completely. When the machine stops, in the stack there may not be any symbol, means stack can be empty, or stack can have one symbol, or stack can have two symbols, or three symbols, or four symbols, or five symbols. We don't bother about the stack. Only three conditions have to be satisfied. One is it has to start from initial ID. When the machine stops, it has to stop in a final state, and the string must be scanned completely. And here alpha, the symbols in the stack can be anything. We don't bother at all about the stack. It can be one symbol or two symbols or zero symbols. Okay. So here QF is the final state and alpha is the stack symbol. So copy this guys. Copy this one. By final state. If M equal to Q comma sigma comma tau so on is a PDA, then the set of all strings accepted by PDA by final state are defined as, copy this one. Okay. So this T of M equal to this one. This. Done? Next. This is about by final state. Next, by empty stack. Look at this. This is the structure of the PDA. Set of states, set of inputs, set of stack symbols, and transient function, initial state, final state. When we are acting the empty stack, means we are not using the. When we are not using the final, then you need not to define the final state. See, if m equal to q comma sigma comma tau comma del comma q naught comma z naught comma f I wrote empty means when you are accepting the string by empty stack, you need not to define the final state. Of course, it is not mandatory. You can take the final state here, but useless. When we are accepting the strings by empty stack, then why should we define the final state? That is the reason I wrote 5. Is a PDA. If m equal to so on is a PDA, then the set of all strings. Then the set of all strings. Right? If m equal to so on is a PDA, then the set of all strings accepted by PDA by empty stack are defined as. Copy this one. Okay. Guys, listen. Whether it is by empty stack or by final state, the strings are combination of input symbols. Whether it is by final state or by empty stack, it has to start from initial ID. It has to start from initial ID. That is u0, w, z0. After one or more transactions, definitely the machines will stop somewhere. When the machine stops, then the string must be empty and stack also must be empty. Means there should not be any symbol in the stack. The stack must be completely empty. Okay? So a string, if it is accepted by PDA, it has to start from initial ID. That is Q0, W, Z0. After one or more transactions, the string must be scanned. When the machine stops here, the string must be scanned completely, means string must be empty, and stack must be empty, means all the symbols in the stack must be deleted. And here Q dash can be any state. It can be any state. It can be Q0, Q1, Q2, any state. We don't at all bother about this state. The state can be anything. Only the two conditions are string must be empty. Suppose string is empty but not stack empty, not accepted. Stack is empty but string is not empty, not accepted. String must be empty, stack must be empty. Then only we say that W is accepted. But here the state can be anything. Now if you go for final state, here also string must be empty, and here also the machine has to start from initial ID. The common in empty stack and by final state, they both must start from initial ID. In both cases, the string must be scanned completely. Whereas by final state, it has to reach the final state. Stack can be anything. Whereas in empty stack, the stack must be empty, and state can be anything. That is the difference. Okay, so copy on. Okay, next. So this is about the concept of PDA. Now we do one design. Take the question. Design a PDA. Design a PDA for the following language. L equal to a power n, b power n greater than or equal to 0. Okay. A power n, b power n greater than or equal to 0. The least value of n is 0. Then a power 0, b power 0, that is epsilon. N is 1, ab, a square, b square, a cube, b cube, so on, a power 100, b power 100, so on. Infinite number of strings will be there. Infinite number of strings will be there. Okay. Here, the PDA accepts a cube, b cube, as well as a power 100, b power 100, because these two are valid. When the machine is accepting this string a cube, b cube, here it cannot count that A's are 3 and B's are 3, and even it cannot check that whether these 3 and 3 are equal or not. And in this A power 100, B power 100, the PDA cannot count that A's are 100 and it cannot count that B's are 100, and even it cannot check whether these numbers are equal or not. Okay. However, the PDA accepts A cube, B cube. The same way A power 100, B power 100 also will be accepted by PDA. But neither here nor here the PDA can count the A's and B's. At the same time, if the string is invalid, see this is invalid, it will be rejected. If A's are more, will be rejected. If B's are more, will be rejected. Suppose A's and B's are equal. See, B power 7, A power 7. This also will be rejected because the order, what is the order? Order is A power n followed by B power n. This is invalid order, so this will be rejected. At the same time, A power 4, B power 4, yes, this is valid. A power 4, B power 4 followed by A power 5, B power 5. This whole string is invalid. This also will be rejected. So, how it is possible without counting the A's and B's, how the machine can accept all the valid, how it can reject the invalid, that we will see. Okay, now I will tell you the logic. First, I'll tell you the logic. Suppose the string is A cube, B cube. Okay, this is input string. Already I told you, when the machine starts, there will be only one symbol in the stack. What is that? Initial stack symbol. Suppose initial stack is Z0. Okay. Whatever the string you take from this language, either A, B or A square, B square, A cube, B cube, any string you take from this language, definitely the first symbol must be A. Okay. And the string will be scanned from left to right. So the first symbol A will be pushed into the stack. The A will be pushed into the stack. Okay. Then the machine will move to the next input symbol. If next input symbol is also A, that A will be pushed again into the stack. Then the machine will move to the next input symbol. If again this is also A, that A also will be pushed into the stack. Like this, whenever A comes, as long as A comes, that A will be pushed into the stack one by one. Okay, after some time, A will be finished in the input string. Then B comes. And B comes for this B, that here we have pushed the 3A's because we have scanned 3A's, all the 3A's will be pushed one by one. So when B comes for this B, we delete the top symbol. Okay, now the machine will move to the next input symbol. When for this B, again we'll pop this, we delete this topmost symbol. Then the machine will move to the next input symbol. Again, when for this B, this topmost symbol will be deleted. Now, what is input string? There is no input string. Completely the string is scanned. So now the string is empty. When the string is empty, if really A's and B's are equal, see, we have scanned 3A's, we have pushed the 3A's for the 3A's. For the scanned 3A's, we have pushed the 3A's. For the 3B's, we have deleted the 3A's. And now the string is empty. If A's and B's are really equal, when the string becomes empty, the top symbol in the stack should be Z0. When the top symbol is Z0, we delete that Z0. Means here stack is also empty. Stack empty, okay, stack empty and string is empty. Means it is accepted. So this is the logic. So how to implement this? Do you understand guys, the logic at least 1%? Hello? Any doubt? Rishikesh? Yes means you have doubt, or do you understood? Okay. Now, we'll go for the design. I will tell you very clearly, okay? If you have any doubt, you can ask me anytime. By taking an example, I will do the design. So whenever you are accepting the string, it has to start from initial ID. So I am taking the Q0 as initial state and W, A cube, B cube and Z0. Q0, W, Z0 is the initial ID. So simultaneously I will do the design and I'll verify the input string. Okay. Any string you take, it has to start from initial ID. That is from initial state. I am taking as initial state. And the first symbol in the input string will be A. And initially there will be Z0 in the inputs. Initially there will be Z0 in the stack. Okay. This is Z0. And so when Q0 is the state, if A is input symbol and top symbol is Z0, okay, this is the present situation, Q0, A, Z0. Guys, what shall I do? What is the logic here? Where as long as A comes, whenever A comes in the input string, so as per the logic, we have to push that A into the stack. So when Q0, A, Z0, I don't change the state. I didn't find any reason to change the state. Unnecessarily don't change the state without reason. Okay, don't change the state without reason. So what is the logic? As per the logic, when Q0, A and Z0, you have to push this A into the stack. So for this reason, I am writing A Z0. Means here Z0 will be as it is. Okay, you keep the Z0 as it is. On top of it, you push the A. That is the meaning of this move. Okay, do you understand? Here Q0 A Z0 means state will be Q0 and Z0 top we will push A. Okay, so we have pushed the A into the stack with the first move. Okay, so what happens after this? What happens? Q0 is the same state. A has scanned, so this is the remaining input string. And after pushing the input symbol A into the stack, these are the symbols from top to bottom. Guys, do you hear me? Hello, do you hear me? Okay. Now, what is the state here? Q0 is the state. And what is the input symbol? A is the input symbol. What is the topmost symbol? A. So, as per the logic, if A comes and top symbol is A, what shall I do this top symbol? You just keep the top symbol as it is. See here, A has to be kept as it is. Okay. When A comes, okay, here I need not to change the state. I don't find any reason to change the state. So the top symbol A will be kept as it is. This is the top symbol. This top symbol I am keeping as it is, and on top of it I am pushing this A. That is the meaning of this one. So here, come to this one. So Q naught is the state, and A is the input symbol, and top symbol is A. So this situation is matched with this move. Okay. So what happened here? Same state. And here it is scanned. So what is the remaining thing? A triple B. So what shall I do? According to this A, you have to push into the stack. Okay, I have pushed it. So now these are the symbols in the stack. Okay. Now again, what is the situation? The present state is Q naught, and the present input symbol is A, and the top symbol is A. This situation is matched with this. This situation is matched with this move. So this move, this single move is sufficient to push all the A's. This is a tool. This is a tool. With this tool, we can push all the A's. As long as A comes, all A's will be pushed. See, this is Q naught A, comma A. So what will happen? Same state, and this A is scanned. For the remaining input symbols are these, and this A will be pushed into the stack. Okay, we have pushed the A's. So all three A's have pushed one by one. Okay, so this is for the first A. This move is for the first A, and with this single move, all as long as A's comes, whether A's are 100 or 1000 or 1 lakh, this move is sufficient to push all those A's. Once A's, all A's are pushed, yes, look at the pushing, all A's are finished. When all A's are finished, then B will come. Look at this. This is the input symbol B. When B comes, already the top symbol is A because we have pushed the A's. So as per the logic, when B comes, the top symbol A, you have to delete this A. For this reason, I wrote epsilon. So Q naught comma B comma A, Q naught comma epsilon. So here Q naught comma B comma A, this condition is matches with this move, So Q naught, same state. This B is scanned now. The remaining input thing is BB. And epsilon, what is the meaning of epsilon? You delete the move from, you delete the A from the stack. So if I delete the A, then these are the remaining input symbols. Again, what is the state? Q naught, B is the input string, and A is the B is the input symbol, A is the top symbol. So Q naught comma B comma A. Again, this move is matched with this present situation. This present condition is matched with this move. So this is the move. Which can pop all the A's whenever, as long as B comes. This single move is sufficient to delete all the A's as long as B comes. Okay, now here this Q naught and B A is matching with this. So what happens here? So the machine will be in the same state, and B will be scanned remaining, and this A will be popped. So remaining A and Z naught. Again, this Q naught comma B comma A, this is matched with this move. So again same Q naught and B means now string is empty. Delete this Z naught. I told you, whenever string empty, the stack contains only Z naught. That indicates A's and B's are equal. So now okay, so according to this, what is the final move? Whenever the string scanned completely, If the stack contains Z0, that indicates A's and B's are equal. Now we delete the stack also. So with this string empty and stack is Z0, delete the stack. Okay, stack is deleted and string empty, stack empty, means this is accepted. So guys, this is the verification for A cube B cube using this design. This is the design. This part is not the design. This is not the design. Only this part is the design, and this part is verification. Okay. So finally, for any string, this is the design. So what is the design here? In this design, what we have used? Listen carefully. Here, this is for the initial A. We have pushed the first A, and after that, this is for to push all the remaining A's, and this is for deleting the for first B, delete the A. Okay, and sorry, I repeat. Delete this. This is the move for deleting the A's for all B's, and finally, this is the acceptance condition. So, what are the states we have used in this design? What are the states we have used in this design? We have used only Q0. And what are the input symbols we have used? A and B. And what are the stack symbols we used? We have used A. We pushed the A and Z0 is the initial stack. And this is a trans function. What is the initial state? Q0. And okay, what is Q0? What is the initial stack symbol? Z0. What is the final state? No final state. That is isn't empty. So this is the structure, and these are the moves. So okay guys, whether you understand or don't understand, no problem. I will repeat again. Just copy this one. So don't copy this. Don't copy this part. This part you need not to copy. This is the design. M equal to states are only one Q0, and input symbols are A and B, stack symbols are. Okay. This is Q, set of states. This is sigma, set of inputs. This is set of stack symbols and trans function. This is Q0, and this is Z0, and this is set of final states. Here no final states, empty. Okay, and this is the design part. Okay, whenever we do any design, that design must be perfect, means it must accept only the valid, and it should not accept even one invalid string. Do you understand? Whenever we do whenever we design any PDA, that PDA must accept all the valid strings. At the same time, it should not accept any invalid string. Okay, guys, this design is perfect. It accepts all the valid strings. Means it accepts all the strings of this language. This design accepts all the strings of A power n, B power n greater than 0. At the same time, this design, this PDA will accept the invalid strings also. Are you following? This PDA accepts the invalid strings also. And what are those invalid strings being accepted by this PDA? I repeat, what are those invalid strings accepted by this PDA? And to overcome that failure, Means failure, na? We are accepting invalid things, means failure. So to overcome that failure, what must we do in this design? That part I will tell you now. Can anybody say the mistake in this one? Anybody? Rishikesh, Samiksha, Simha, Smita, Kiran, anybody? What is the mistake in this? This is not perfect design for A4 and B4. So what is the mistake in this? Anybody? Do you know? Okay, I'll tell you. Guys, tell me, is this string valid or invalid? Hello, A cube, B cube, of course valid. And is this total string is valid or invalid? This total string A cube, B cube, A square, B square. No, this is invalid string. What is the language here? The language is any number of A's followed by that many number of B's. If A's are 100 followed by B should be 100. That's only. Again A's, again B should not come. This is invalid. So this string should be rejected. This string should not be accepted by this design. Okay, let us see whether it is accepted or not. Guys, listen. Q0 is the state and input symbol is A and top symbol is Z0. Q0 A Z0. This present situation matched with this move. Q0 A comma Z0. So what happens here? So same state Q0. Okay, state will be Q0 and the machine has scanned. So the remaining input string will be AA, triple B, AA, BB, and A Z0 means this A will be pushed into the stack. Okay, next Q0 A and A, Q0 comma A comma A. This is matched with this move. Okay, so what happens? Same state. Here it has scanned A, so remaining inputs will be A, triple B, double A, double B, and this A will be pushed into the stack as per this move. Okay, next again this is Q0 A comma A. Again this is also matched with this move. Okay, so what happens here? The machine will be in the same state and the remaining inputs will be triple B, double A, double B, and this A will be pushed into the stack. Now we have scanned 3 A's. We have scanned 3 A's. We have scanned 3 A's and those 3 A's we have pushed into the stack. Now the state is Q0, input symbol is B and the top symbol is A. Q0 comma B comma A. This is matching with this. So what happens here? So Q0, the input string has this B has scanned. So remaining input string is BB, double A, double B. So same state Q0. Okay, I wrote that. Epsilon. What does it means? You delete this A. Okay, I deleted this. Again, this is Q0 and B comma A. This is also matched with this one. Okay, same state. Again, same state. And B, the machine has scanned this B and remaining input string and delete epsilon. Epsilon means delete the A. Okay, this A will be scanned. And this is the remaining input string. And again Q0 B A. So for this B, this A will be deleted. So what will be the result? So Q0 and double A. So what will be the result here? For this B, when A is deleted, Q0, double A, double B, and Z0. Now guys, look at this situation. Q0 is the state. I repeat again. I write again. Q0 is the state and AA is the input string and Z0 is the stack symbol because this A is deleted. Now again the machine has reached Q0. This is W and Z0. The machine has reached to the initial position. Q0 A Z0. This is the present situation. So this Q0 comma A comma Z0. This move is matching with this. This present situation is matching with this move. So according to this move, what happens here? This A scan. This is the remaining input string, and the A will be pushed into the stack. And again Q0 comma A comma A. Q0 comma A comma A. This is matching with this move. So this A will be pushed again. Q0 comma B, and this A will be pushed into the stack. And now Q0 comma B comma A. This is matching with this. So for this B, this A. Again for this B, this A. So what will come? Q0 and epsilon and Z0. Q0 comma epsilon comma Z0 with this. So what happens here? Q0 epsilon and Z0 is epsilon. So string empty, stack empty means this A cube, B cube, A square, B square is accepted. Which is an inverse string is accepted, in which the design PDA is not perfect. Okay, so an inverse string must be rejected. Every valid string must be accepted. So what is the mistake in this one? There is no mistake in the logic. The mistake is in the design only. I repeat, there is no mistake in the logic. The logic is perfect. The mistake is in the design part only. So what to do? So what is happening here? If you look at this design in this input string, 3 A's we are scanning and all 3 A's we are pushing. And when B comes, for every B we are deleting. For 3 B's we are deleting 3 A's. After some time, the machine coming to this position. So what? Q0. Let's hold on. Okay, this is the input string. What is happening here? We are pushing the 3 A's one by one into the stack. When B comes, for B this A, for this B this A, for this B this A, we are deleting the A for every B. Then the machine is coming to this position. So this is for 3 B's, for 3 A's are deleted. Now the machine comes to this position. So what is happening here? The machine has reached Q0 comma W Z0. The machine has reached to the initial position. Again, what is happening? These 2 A's are being pushed. And for these 2 B's, these 2 A's are deleted. Then the machine is coming to Q0 comma epsilon comma Z0. Then Q0 comma epsilon comma epsilon. The string is accepted. Okay. Now the mistake here, for 3 B's we are deleting the 3 A's. After that the machine is coming to this initial position, and after that again these 2 A's are being pushed. For these 2 B's, those 2 A's are again popped. So if we avoid the machine to come to this position, this initial position, so that this A will not be pushed into the stack, then the problem will be solved. So for that, I repeat guys, here the mistake here is when you are pushing the A's and when you are popping the A's, the machine is coming to the initial position. So we have to avoid the machine to come to the initial position again. Then if we avoid that, then the problem will be solved. So for that, what should we do? So look at this. So guys, here A will be pushed. This is for the first A. For the remaining A's, all A's will be pushed with this move. And when A's are finished, when B comes, the top symbol A must be deleted. The top symbol A must be deleted. When you are deleting for the first time, change the state. Change the state to Q1. Okay, change the state to Q1. If you change the state, then the problem will be solved. Okay, so I am changing the state to Q0 to Q1, and same thing, A will be popped. Now, for the first time we have changed the state, so now the machine is in Q1. Again B comes, the top symbol is A. So the top symbol A will be deleted. Now you need not to change the state. Only first time we change the state. And finally, when machine is in Q1, the string is empty, the top symbol is Z0, then delete the Z0. So string empty, stack empty. This is the perfect design. Now guys, in simply one or two steps, I will explain this design. Look at this. Here Q0 comma A comma Z0. So after few steps, after 3 steps, 3 A's will be pushed. Now Q0 comma B comma A, this is matching with this situation. So what happens here? Q0 comma B comma A. According to this, the machine changes to Q1. So the remaining input string will be BB, AA, BB. For this B, we are deleting A because this is epsilon. Now these are the remaining A's. Now Q1 comma B comma A. This is matched with this situation, with this move. So for this B, this A will be deleted. For this B, this A will be deleted. So after 2 steps, Q1, AA, BB, and Z0. Now Q1 is the state, and A is the input symbol, and Z0 is the stack symbol. Q1 comma A comma Z0. See, Q1 comma A comma Z0 is not there in the design. So what happens here? Q1 comma A comma Z0 is not there, but we have this move. What is that? Q1 and Z0. So Q1 is the state, Q1 is the state, and Z0 is the stack symbol. So these two are matched. So this is matched with this move. So what happens here? It will make a null move, means without taking the input symbol. What is the next state? Q1 is the state. It is not taking the input symbol. So same input string will be scanned. It will be continued. And Z0, delete the Z0. So stack empty. When the stack empty, immediately the machine stops. The machine stops here. When the stack empty, the string is said to be accepted if the string is empty. Is the string empty? No. If the string is not empty, the string is not accepted. Now, this is the perfect design. Okay? Guys, if you have any doubt, I will explain you tomorrow also. Just go to this. Once you go through this, so here the states are the design is here. The states are, how many states we have used? 2 states, Q0 and Q1, and the inputs are A and B. And stack symbols are, what are the symbols we are pushing? A and Z0 in the stack. And del is the transient function. Initial state Q0, initial stack symbol Z0, and 0 final state. This is the structure, and this is the design. Guys, this is the structure, and this is the design. So copy this. So the previous design is not perfect. Why? Because it is accepting some of the invalid strings. Okay, here one more move we have to write. That is, what is the n value minimum? 0. So epsilon must be accepted. So for the epsilon q naught, when the machine is in q naught, epsilon must be accepted. So when epsilon comes, we have to delete the stack symbol. You change the state or don't change the state, no problem. Q naught come epsilon. So copy this also. The last step for epsilon move, sorry, epsilon string. Okay, now ask me if you have any doubt. So tomorrow I will tell you something about this same question. Okay, if you are clear, if you don't have any doubts, then we'll move forward to the next questions. So really you will enjoy these logics if you understand. Okay, any doubts? Samiksha, Smita or Rishikesh, Kiran, any doubts? Hello, are you there? Okay, so go through this once. Tomorrow, please maintain the timing. Samiksha, why are you late? You didn't give me the reply. You are almost more than 40 minutes late. What happened? Please maintain the timing. Say something. Oh, interview. Okay. Okay. Tomorrow will you come at 5 o'clock, all of you? 5 to 7. Okay, no problem. You have some other, you are busy with something else, na? That's good. Okay, it's good. But, okay, what about tomorrow? Tomorrow also you have the interview? Okay. At what time you can attend for tomorrow's class? At what time? Tomorrow? 5 or 5:30 or 6? What do you say? What about you, Smita? Smita, you are also late. Okay. At least do one thing. You know my number now. I have given you my WhatsApp number. You just message me at what time you can attend, whether you are attending or not, because I am waiting for you. Because from your college, very few people are attending. Only 5 or 6 people. Okay. So if you have given passed the information, so that I can't wait for you. Okay. I don't wait for you. Okay. Tomorrow, 5 o'clock. Okay.